Okay, our topic is composite functions. So make some notes on your learning objective. When you're ready, click play and we move on. So composite functions are where we've got two or more functions combined. So in this case, we've got the function f of g of x. So we apply g of x first in the first instance, and then we apply f to the function g of x. We can write it in either of these forms. So f g of x is much more simple, or you could write it as f of g of x in brackets. Okay, so what we're doing is, as you can see, we're applying the function g first to x, and then we apply the function f to all of g of x. The order in which we apply it is crucial, it's important, and in this case written f of g of x. If it was written in the other way, g of f of x, then we'd have to apply f of x first and then apply g to it. So what I want you to do is to make some notes. You're going to need that, and anything else you think. The order is important. Right, an example. So let's have a go at that. We're given f of x as x squared, g of x as x add 1. Find f of g of x and then find g of f of x. So for A, g of x is given by x add 1. And now f of x is equal to x squared. That means if we're going to apply g of x, so f, wherever we've got x, now becomes g of x. That's going to be equal to, wherever I've got x, and I apply what g of x is. So that's x plus 1 squared, which is going to be given by x squared plus 2x plus 1. And that's your f of g of x. I'm just going to write it in a slightly different way, so you can see either of these forms is the same. Okay, let's try part B. This time we're finding g of f of x. So f of x first is x squared. Then g of the function f of x is equal to, oops, for my bracket there. So this time, wherever I've got x, I apply f of x to it, or x squared. Now g of x is x plus 1, so that becomes x squared plus 1. Okay, so hit pause, make some notes. When you're ready to move on, hit play again. Squared, that is good. So we've got a second example. This time we've got to f of x is 3x plus 2, g of x is x squared plus 4, and we've got quite a few things to find. F of g of x, g of f of x. Now f squared x means we apply f of x to f of x. We'll come to that, and then find the values of b such that f of gb equals 62, which is going to be the first function we find. We're going to equate it to 62. Okay. Right. So we start with A. Down here. For A, we've got to find f of g of x. Now g of x is given by x squared add 4. So that means that f of g of x, I'll use the brackets for now, it's going to be equal to, the function f of x is 3x plus 2, so that becomes 3, and wherever we got x becomes the g of x, so that's x squared plus 4 plus 2, which is equal to 3x squared plus 12 plus 2, which is equal to 3x squared plus 14. And that's your f of g of x. So that's part A. Let's have a look at part B. This time they want us to find g of f of x. Now f of x is equal to 3x plus 2. So g of f of x, well let's have a look what g of x is. G of x is given by x squared plus 4. So g of f of x, that's a g, it's going to be equal to, wherever I've got x, I sub in for f of x. So it becomes 3x plus 2 squared plus 4, which is going to be equal to, what have we got there, 9x squared plus 12x plus 4 plus the 4 on the end. So that's 9x squared plus 12x plus 8. So we've got our A and B. Part C, I seem to have lost part D, there it is. Part C is f squared of x. So let's do part C over here. Right, just change the color of my pen. Part C. Part C, we want to find f squared of x. Now this is the same thing as f of x. Oops. So I've got f of x first, and then I apply f to it. So f of x is given by 3x plus 2. So f of x is given by 3, and wherever I've got x, I apply f of x to it. So 3x plus 2 plus 2. So that gives me 9x plus 6 plus 2, which is 9x plus 8. And finally, part D. Part D, find the values of b such that f of gb equals 62. Now, f of g of x, we worked that out earlier. F of g of x is equal to 3x squared plus 14. And we're going to set that equal to 62. So 3x squared plus 14 equals 62, and we're going to work out the value of x then. Solve the equation. So 3x squared is going to be equal to 62 minus 14, which is 48, I believe. So 3x squared equals 48. It's interesting. I was just looking back at the question. It says the values, and this is x squared. So we'll have two values. X squared equals 48 divided by 3, which is 16. That means that x is a square root of 16, which is plus or minus 4. So that's question, the second example. So make some notes. Hit pause, make some notes. When you're ready, hit play again. Look at another example. Okay, another example. I'm sticking with the blue ink this time. So, functions f and g. F of x is given by the modulus of 2x minus 8, and g of x is given by x plus 1 over 2. Part A, find f of g of 3, and then part B, solve f of g of x equals x. So in part A, we need to find f of g of 3. Now g of x is given by, we can just write it as is equal to, it's a different notation, they use the arrow, but I feel quite happy writing this. So x add 1 over 2, as opposed to using this notation the whole way through. Now that means that g of 3 is going to be equal to 3 add 1 divided by 2, which is 4 over 2, which is 2. So f of g of 3 is going to be equal to, let's put this as therefore, f of g of 3 is going to be equal to the modulus then of 2. Now wherever I've got x, I've got to put that g of 3, which is 2, minus 8. So that's going to be the modulus of 4 minus 8. So it's the modulus of minus 4. So that means that f of g of 3 is equal to 4. I'm going to change my pen again. And this time go back to red for part B. Part B, I want to find f of g of x and then equate it to x. Now g of x is equal to x plus 1 over 2. F of x is equal to modulus of 2x minus 8. So f of g of x is going to be equal to the modulus then of 2 times x plus 1 over 2 minus 8, which is equal to, the 2's cancel, so it's going to give me the modulus of x plus 1 minus 8, which is equal to the modulus of x minus 7. That's f of g of x is equal to modulus of 7. Oops, got my modulus there. Now they're telling me that in the question f of g of x equals x, so I need to solve that. Now we can sketch it. I'm going to sketch it here because I'm going to use this bit for my workings. Quick sketch of the modulus of x minus 7. I'll draw a line here. It's a positive gradient, so it goes like that. But it's reflected, so let's draw it like so, and the reflected part, if I get a chance to draw it again, oops, let's try again, there we go, that's the reflected part. See if I can make this any better. So that's my modulus, and I've got to equate it to x is equal to equate it to x. So it's going to intersect here. I'm going to change color again. Let's use a blue pen this time. There we go. Good. So it's going to intersect there. I've got one solution for that one there. So let's work through it then. Don't forget to label, just in case. That's your x, y equals x, or function equals x. This is your modulus function. I'm going to change ink again. Let's go back to red. There you go. This is your modulus function. Y is equal to the modulus of x minus 7. That's your y-axis. That's your x-axis. Okay, good. That's the origin. So there's one intercept there. is intercepting the negative part of the modulus. This part has no solution. You can see that if you say x minus 7 equals x, then there's no solution there because they don't intersect. On the negative part though, our solution is going to be given by minus x minus 7 equals x. So minus x plus 7 equals x. 7 is going to be equal to x add x. Let's do it in full. So we can say 2x is equal to 7, and so x is equal to 7 over 2, which is equal to 3.5. And there's your solution. Good. So what I want you to do now is hit pause and make some notes. And I think it's your turn to attempt some questions now. So your exercise is exercise 2C on page 34 of the book. And you go up to question 11. Good luck. Enjoy.